Look at this diagram and notice the axis. Can you see the axis there? Notice that the axis is pointing in the same direction as the Earth goes around the sun. It doesn't matter where the Earth is, the axis is always pointed in the same direction. Can you see that? There it is. This fact is called parallelism. Parallelism describes the fact that the Earth's axis is always pointed in the same direction, which, by the way, is towards Polaris, also known as the North Star. Where this term comes from is this. It has nothing to do with parallels and lines of latitude. It's also describing the fact that each position is parallel to every former position. In other words, today, Tuesday, the Earth's axis is parallel to where it was on Monday, which is parallel to where it was on Sunday, which is parallel to where it was on Saturday, and so on. Now look at the circle of illumination here. The olive arrows are pointing at the circle of illumination. Notice with the part of the diagram that says June solstice, the right side of the Earth is illuminated because it faces the sun, and the left side of the Earth is in darkness. In other words, it's night because it's not facing the sun. If you go over and look at the December solstice on the right-hand side, you can see that it's exactly the opposite. The left-hand side of the Earth is facing the sun, it's illuminated, the right-hand side is in darkness. What's going on with the September and March equinoxes? You have to envision yourself being very far out in space and watching the Earth revolve, orbit around the sun. If you do that, you are looking at the back side of the Earth, the darkened half, the nighttime side of the Earth with the September equinox, and you're looking at the Earth in full illumination when you're looking at the March equinox. It's somewhat similar to the way the moon works with a full moon and the first and third quarter phases. Now take a look here at this next diagram. Notice where the circle of illumination is, and notice also that each one of these Earths is labeled as A, B, C, and D. The way I'm going to go through this is I'm going to start speaking about A and then C. I'm then going to elaborate a bit more on A and C and then come back and pick up B and D. I just put the equator on there. Can you see the equator? There's a lot of lines on these diagrams. I want to make sure that you can see where the equator is. 0 degrees, splitting the Earth into two equal halves, the northern and southern hemispheres. Let's start with position A. At position A, these are the things that you need to notice. First of all, from the northern hemisphere, the Earth's axis is tilted toward the sun. I'm not saying it's pointing directly at it like the red arrow, but the axis itself is tilted toward the sun from the northern hemisphere. Can you see that? Just take a look over at position C and notice the way the Earth's axis is going to be at position C from the northern hemisphere. Good. Also notice this. At position A, most of the northern hemisphere is in daylight. If you compare that to the southern hemisphere, most of the southern hemisphere is in darkness. This is, in the northern hemisphere, the longest day of the year and the shortest night of the year. So in other words, the sun is going to rise at its earliest time and it's going to set at its latest time. Additionally, in the northern hemisphere, on this day, if you looked up at the sun at noon, you would notice that the sun is at its highest angle in the sky for the year. In the northern hemisphere, this is the first day of summer. Because of that, this is known as the summer solstice. Solstice is a Latin word. It means sun, that's the sol part, standing still, that's the stike part. The summer solstice in the northern hemisphere begins on June 21st or 22nd. It varies annually. With regard to the southern hemisphere and what's happening at position A, all we have to do is flip all of this over and we'll have what goes on in the southern hemisphere, because the southern hemisphere has opposite seasons from the northern hemisphere. Let's do it. So at position A, notice this. In the southern hemisphere, the axis of the Earth from the southern hemisphere is tilted away from the sun. And with the northern hemisphere, we have a greater amount of daylight in the northern hemisphere. In the southern hemisphere, there's less daylight. and there's more darkness. This is the shortest day of the year in the southern hemisphere and the longest night of the year. The sun is at its lowest angle in the sky, and this is also the first day of a season. But of course, in the southern hemisphere, if you were in Chile or Australia, you would not be calling this the summer solstice. This would be the winter solstice, so it would be ushering in the first day of winter. Because of that, when we discuss the solstices, you really need to make it apparent whether you were talking about the summer solstice in the northern hemisphere or the southern hemisphere, or the winter solstice in the northern hemisphere or the southern hemisphere. Therefore, if you just use the term June solstice, this works with everyone. Let's look over here at position C. At position C, once again, let's take a look at the axial tilt. Notice that from the northern hemisphere, the axis is now tilted away from the sun. And more of the southern hemisphere is illuminated than the northern hemisphere. See that? There's the southern hemisphere, there's the northern hemisphere. Northern hemisphere, not a lot of illumination. Southern hemisphere, lots of illumination. This is the shortest day of the year in the northern hemisphere and the longest night of the year. Can you feel what time of the year that would be? And the sun is at its lowest angle in the sky for the year. So if you looked up at the sun at 12 noon on this day, the sun would be at its lowest angle in the sky in the northern hemisphere. This is the first day of winter in the northern hemisphere. And because of that, we call this the winter solstice in the northern hemisphere. This occurs on December 21st or 22nd. It varies annually. In the southern hemisphere, you just flip all of this over. So you can see that in the southern hemisphere, position C, the axis of the earth is tilted toward the sun. More of the southern hemisphere is in daylight than the northern hemisphere. This is the longest day of the year and the shortest night of the year in the southern hemisphere. The sun is at its highest angle in the sky for the year. And of course, they would not be calling this the winter solstice in Chile or Australia. This would be the summer solstice because it's the first day of summer. Because of that, if you just refer to this as the December solstice, you can't really go wrong.